Evaluating a variable expression. A variable expression is such as 3x squared minus 4x y plus 5x minus y minus 7. This variable expression has 1, 2, 3, 4, 5 terms. 3x squared is a term. Minus 4xy is a term. 5x is also a term. Minus y is a term. Minus 7 is also a term. This term, minus 7, is called constant because it doesn't have a variable part. It's only a number. So this term here is a constant. If we take, for example, 3x squared. 3x squared has two parts. The first part is 3, which is the numerical coefficient. The second part is the variable part. Variable part. So 3x squared has two parts, the numerical coefficient and the variable part. Similarly, because we already took 3x squared, this has the leading coefficient or the numerical coefficient is minus 4 and the variable part is xy. Here the leading coefficient is 5 and the variable part is x. And here the leading coefficient is minus 1. Minus 1. We are going to talk about what do we mean by minus 1 and why we didn't write it. And if minus 1 is the leading coefficient or the numerical coefficient, y is the numerical part. Minus 7 is the constant. So it's important, as we saw before, at minus y, okay? Or for example, if we say plus y, okay? Here the leading coefficient or the numerical coefficient is 1. Coefficient is minus 1, not 1, minus 1. And here the leading or the numerical coefficient is 1. So it's important to know that if it is the numerical coefficient for a variable in a term is 1, if it is 1 or minus 1, it is not written. Only the sign, whether if it is negative or positive. That's it. This means the coefficient here is minus 1 and the coefficient here is 1. To evaluate a variable expression, replace the variables by their given values and then use the order of operations agreement to simplify the result. Again, to evaluate a variable expression, replace the variables by their given values. This is 1. And then use the order of operations agreement to simplify the result. This is number 2. To evaluate a variable expression, replace the variables by their given values and then use the order of operations agreement to simplify the results. If this example comes to you, evaluate a variable expression. Okay, the variable expression is this: x cubed minus y cubed over x squared minus xy plus y squared when x equals 2 and y equals minus 3. As we remember, to evaluate an expression, replace by the given values first. This is the solution. And then use the order of operations agreement to simplify the results. So first we replace by the given values. To simplify, x cubed minus y cubed over x squared minus xy plus y squared equals, when we replace by the given value, x equals 2, right? So x cubed means 2 cubed minus y cubed, y equals minus 3, so then it is minus 3 cubed, okay, over x squared, x already 2 squared, minus xy, this means minus multiplied in x, which is 2, multiplied in y, which is minus 3, plus y squared, which is plus minus 3 all squared. So this is equals to, then we'll use order of operation agreements. This means exponentials are first. So 2 to the power cube is 8 minus 3 to the power cube means minus 27, okay, over 4, 2 to the power 2 is 4, minus 2 multiplied in minus 3, which is plus 6, okay, but we will leave it because we would like to follow the agreement, and we start by exponential expressions first. So in later time, as you practice more and more, you will do it automatically, and the agreement will be in your mind without following it. So this will be kept the same. However, the exponential we have to expand. So minus 3 squared is 9. Then this is equal 8 negative, multiply negative is positive, so 8 plus 27 over 4 minus 2 multiplied in minus 3, this means plus 6, then plus 9, and do the addition from left to right. 8 plus 27 is 35 over 19. That's it. Now let's take question B. B, x plus 2y to the power square minus 4z when x equals minus 2, y equals 3, and z equals minus 4. So we first replace by the given variable. So this equals to minus 2 instead of x, right? And plus 2 multiplied in y, which is 3 to the power square, minus 4 multiplied in z, which is minus 4. Now we will follow the agreement, so we will work inside the parentheses. So it should be minus 2 plus 6, and we start by multiplication and division, as you remember, from left to right. So this is left as the same, and we have done the multiplication to the power square, minus 4 multiplied in minus 4. We can simplify this and we do not wait, so it should be plus 16. Okay, so this is equal to 4 squared plus 16, then it should be 16 plus 16, which is 32. We are done. Let's take now another example. Z minus y all to the power square minus 3z cubed when x equals 3 y equals minus 2, z equals minus 1. Solution equals what when we replace? So it should be here z, then it should be minus 1 minus 2 multiplied in y, which is minus 2, all to the power square, minus 3 multiplied in z cube, which is minus 1 cube. Okay, so this is equal to, finish what is inside the parentheses, minus 1 minus 2 multiplied in minus 2, this is plus 4, all to the power 2, minus 3 multiplied, minus 1 cube is minus 1. So this is equal 3 square minus 3 multiplied in minus 1 should be plus 3. So 3 square is 9 plus 3. 9 plus 3, which is 12, and we are done.